of Hadoop as managing these multiple nodes and the files and the folders that are on the multiple nodes and the programs that are going to run on them, and think of it as an analogy to a regular operating system. So what does the regular operating system do? As I just mentioned, it handles the CPU, which program will have the CPU at what time. It handles the input and output to the machine, and it handles all the devices that are connected to it, including keyboard, monitor, and all these things. And more importantly, it manages the main memory, the disks, and the file system. So what files are stored and where are the files located and how we can access them. So we have the same situation with this Hadoop that is going to manage very similar things. However, instead of managing them on a single machine, it will manage them on multiple machines. So we will talk about the distributed file system, which is distributed because it makes it seem like a one file system, just like we have on our laptop, when in reality the pieces are spread among multiple machines somewhere on the network. So how does that look like, and what are its goals, and what functions does it have? We will look at that. The MapReduce, we already talked about it. It's a programming mechanism that can run on the top of this Hadoop platform to process batch jobs such as counting words or all of these other things that we do here. Sorting files, categorizing libraries, doing searching through web pages, and so on. So that is one type of a program or job that can run on this Hadoop platform. There are, of course, many others, such as this. Pig, for example, is a programming language that is very easy to program, and its code is very concise, that can run on the Hadoop. Also, HBase is and Hive. These are other tools of programming models that can run over Hadoop that will allow for processing of data similar to the way we will process it on a relational database. So when we have rows and columns and we can send a query to the database, let's say give me all the customers of age bigger than 25 and that live in specific zip code or have a master's degree. That's a query which cannot normally run in a MapReduce, because the MapReduce is primarily designed to work as a batch job and search through large text files. So it is not very well suited for relational data format. And to mimic that, we have this Hive and HBase and other tools that can run on Hadoop to run in SQL type, to run queries in SQL fashion on a data that is distributed in the cluster over this distributed file system. So the Hadoop is pretty much the platform, pretty much similar to a distributed operating system that's going to handle the file system over these multiple machines. So that is a process Hadoop can be used to process large data sets over these distributed computers as a platform. So to run different tools on it, whether that be MapReduce for huge text files, or this Hive and HBase for relational database type of files, or it could be a completely unstructured files, or such as web logs, or whether it is semi-structured data like XML files that have tags to give partial structure. So, or whether that is web pages or a graph of some form, such as the web pages, which page links to which page. These are the different data types that can be processed. Okay, so why do we need this Hadoop? One reason is to process these big data sets, right? The scalability. Another reason is because of reliability. So Hadoop provides reliability in a sense that when one node fails, it is going to relaunch the job on another node, and these failures are expected every day because the machines that are used are regular commodity computers. They are nothing special, so they can fail. And the other reason why we need it is because it is efficient, because it handles these failures, and reliable because it handles these failures, and efficient because of the date of the models, the programming models that we mentioned, and the way it places the data in locations that are near the data processing modes, and it is easy to use. So this Hadoop is an open source system, and it can be obtained by Apache license. Who is using it? We mentioned here Amazon was using it for orders processing. Other companies are using, such as Facebook and Google, primarily because they have lots of data, right? We have all these people posting messages and pictures on this Facebook. Imagine how much data is that per day that they have to store, and every day this data is growing. We want to search. What did our friends say yesterday, or what did they say 5 years ago? Well, Facebook has to go through a lot of data to find that for us. A regular query sent to a relational database may not work just because the data is so huge. And it is in a flat text files or pictures or something like that that is not a relational format, and it's hard to send a query to something like that. That's pretty much why these Hadoop and MapReduce systems were invented. Google is using it because they have unstructured data. Unstructured data means that it's not in a table with rows and columns, but it's flat text files, or it's videos, or it is pictures, or something to that extent. In this case, it's web pages. And the Google has to search through all these web pages. That's a lot of pages to search through to give us the results. So they are using the Hadoop system, and many others with similar issues, such as publishers of newspapers that have lots of text files, and other search engines, and many more. So let's see the overall architecture of Hadoop. We have briefly seen these last time. They are the nodes. These are the data nodes that we just mentioned. So the data nodes that store the data and do the processing. It's a two-level architecture. The one level is here, which is the green level, with the green arrows. These nodes are connected together through a network switch, and the speed is, or the bandwidth, and they can transfer 1 gigabit of data per second. So that is the speed of that particular network connection. So this first level switch is connecting these data nodes together. The switches themselves are connected by the red line, which is an aggregation switch, so that is the level 2. And you see the red line, that is a faster connection. That can send 8 gigabits per second. That is the speed. So the nodes are commodity, everyday personal computers. In a rack, there could be 30 to 40 nodes. So imagine this is a rack, and you can have 30 to 40 computers in that rack. And so the rack, the computers themselves are connected between each other. and then each rack is connected to all the other racks through this aggregation switch. So the uplink, it could be up to 8 gigabits. The internal rack is 1 gigabit per second, the speed.